derived quantities. Derived quantities are dependent on other quantities and are defined by other quantities. They can also be obtained by simple combination of the other quantities. So why fundamental quantities cannot be obtained by what now? Combination of other quantities, derived quantities can be. So I will try something very quickly. I just hope you can tag along. Let's do this. Okay. Alright. So, for example, if I'm doing area is given as length times length. And please let me emphasize. In physics, when we're talking about length, length has to do with what now? Any space, line space between one point to another. So anything that you measure in that regard is termed as length under measurement. For example, if I move from here to town, I have covered what now? A particular what now? Line segment. It's not necessarily a straight line and all that. So distance is an example of length. The radius of a cycle is an example of length. Height is an example of length. Depth. Understand that the difference between height and depth is that for one you're measuring from bottom upwards, for the other one you're measuring upward now, downward. So height and depth can be the same thing. The only difference is that one you're measuring from bottom to the top, that's height. If you're measuring from top to the bottom is what now? Depth. For any particular object, for any particular thing, the height and depth should be what now? The same. Alright? So there are other distances like circumferences. Perimeter. All of those are what now? They are lengths. They are all different. Even thickness. Thickness, because you encounter all these things. Width or breadth. The breadth or width. All of these are classified under length. So anytime you're looking for area, it's always two of these different lengths that you must combine. You must combine two of them to get what now? Area. So for area is always a combination of two lengths. Area is always the combination of two lengths. So I have length times length, and that is why the unit is also what now going to be meter times meter, which is going to give me what? Meter square. The unit for length is meter. So since I'm having two lengths multiplying each other, meter times meter will give me what now? Meter square. So the unit for area is what? It's meter square. Another thing that we could have, another quantity rather, is volume. Any volume at all that you're dealing with has to do with what now? Three lengths multiplying each other. You already know the unit, I guess. Length times length times length means what now? Meter, meter, meter. So give me what now? Meter cube. The unit for the volume is going to be meter cube. Then if I have velocity, velocity or what now? Or speed. If I have speed or velocity, I want to emphasize as I'm doing this. What is speed? Speed is what now? The rate of change of distance with time. The rate of change of distance with time. What is velocity? Velocity is the rate of change of displacement with time. The rate of change of displacement with time, velocity. Rate of change of distance with time is speed. What's the difference? This is scalar, doesn't have direction. So speed is a scalar quantity. The vector for speed is called what now? It's called velocity. Because displacement has to do with distance, very an instant. If I say I travel 40 kilometers, that's distance. If I say I travel 40 kilometers due west, I get direction. That is what now? Displacement. If I say I traveled 5 meters to the staff office, is what now? Is displacement, because I'm giving what? Direction. For displacement, there's direction. For distance, there's no what now? No direction. But both of them have the same what now unit, because the unit of distance is meter And the unit of displacement is also what now? Meter. Because displacement is distance with direction. So displacement is a kind of distance, just as velocity is a kind of what now? Of speed. I'm sure you're getting all of this. Let's go further as quickly as possible. So if what I just showed you is true, it means that what? Both speed and velocity should have the same what now? The same unit. Which is going to be what? You're having distance, which is length over what? Over time. Length over what? Over time. If I have length over time, length is meter times what? Seconds. Meaning that the unit is going to be what now? Meter per second. Or if you want to write it the other way, for those of you that have done indices, I can write meter per second like this. They are both the same. Meter per second, meter per second. So the unit for velocity or unit for speed is going to be what? Meters per second. And I say you can write it like this also. It doesn't stop it. Alright? The next thing I'm going to talk about is what? Is acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. The rate of change of velocity with time is acceleration. Velocity with time, acceleration. Now what is the velocity is? Velocity is length over time. So if I have length over time, and then I have another time again dividing, length over time, this is already what now? Velocity. Length over time, meaning that I'm going to end up having length over time squared. Length over time, time times time. One time is already at the bottom, then I'm bringing time again. This is what? This is velocity. This one is velocity. Divide by what? Now by time. So at the end of the day, I'm going to have that what? That acceleration is length over what? Over time squared, which is going to give me what? Meter per second squared. Time squared, second squared, length meter. So I could write it as meter per second what now? Per second squared. It's all what now? All the same, all good. Okay, let me find a way to compress this a little bit. Because I really needed it for some other explanation. I hope you can see that. Okay. Then if I go further, I could be doing something like density. Density is given as what? As mass divided by volume, or mass per unit volume. Mass over volume. That is density. Density is given as mass what now? Per unit volume. So what is the mass? Mass we already said is what? Kilogram. If you remember, from fundamental quantities, from fundamental quantities, we say mass is what? Kilogram. The unit of mass is kilogram. Unit of length is what now? Is mass. It's meter. And unit of time is what? Is second. So let's go back. Mass becomes what? Kilogram. Over what? Okay, sorry. Let me give you the dimension. Dimension, mass is capital letter M for dimensioning. Capital letter M. And then we're writing that volume is what? Length times length times length. That's what? Length to the power of 3. Length cube. So I end up getting what? Mass will be what? Mass is kilogram per meter cube. Kilogram for mass. Length cube is meter what now? Meter cube. This is the unit for what? For density. Mass over volume is density. The unit is what? Kilogram per meter cube. And then the dimension, which I'll talk about later, is M what now? L cube. M over L cube. So if I want to write dimension, I can write it like this. Or that. Okay. Then we have force. Force is mass times acceleration. Force is mass times acceleration. What is mass? Mass is kilogram. This is M. And acceleration is what? Acceleration is L over what? Over T squared. Pardon there. Acceleration is L over T squared. So mass times acceleration is M L over T squared. So if I'm writing the unit, it's going to be kilogram meter per second squared. Or if you like, you can write in this notation. It's the same thing. However, because of the fact that Newton did a lot of work under what now? Force. To honor him, His name was used now to replace what? This unit. So instead of us writing kilogram meter per second squared, we now write what? Newton as the unit of force, or just N as the unit of what now? Of force. So that is for force. And mind you, in examination, they could ask you, which of the following is the unit of force? They will use Newton. They will use what? Kilogram meter per what? Per second squared. So in case you see this, also know that this is what? The unit of force. Alright? Then we have pressure. What is pressure? Pressure is what? Is force over area. Force over area. Remember, sorry. Oh, no, that's going to be too far. Force over area. We already said that force is what? Kilogram meter per. Force was ml over what? Over t squared. Right? So if this is force, and then area is what? Area is L squared. Area has to be at the bottom. If I put L squared at the bottom, one of the L will cancel the remaining one. One of the L will cancel the one on top. So L will cancel L. So at the end of the day, I'll get M over what? L t squared. I'll have one L at the bottom. So if I'm going to write the unit of what? Of pressure, it's going to be what? Take note. I said force under dimensioning, we said is what? ML over what? T squared. Right? So if I now put area, force over area, area is L squared. L squared is here. L squared means L times L. So one of the L will be cancelled by the L on top. Right? So eventually I'm going to get what? M remaining on top. At the bottom I have L and what? T squared at the bottom. So what does this tell you? It tells you that what? The unit of force from here. Sorry. The unit of force from here can be said to be what? Kilogram kilogram per meter per second squared. The unit of pressure, kilogram per meter per second squared. Kilogram per meter per second square. But because of the fact that Pascal also did a whole lot on pressure, to honor him, they said that what? The unit of force, of pressure rather, should be what now? Pascal. Pascal. The unit of pressure should be what now? Pascal. PA. This is the unit of what? Of pressure. And we can remember that what? We said that the unit of force is Newton, right? And the unit of area is what? Meter squared. So I can also have what now? Newton over what? Meter squared. Newton per meter squared. All of these are units of force. Newton per meter squared, Pascal, kilogram per meter per second squared. All these values, all of them are units for what now? For pressure. Anyone you see in examination is what? Is acceptable. In fact, for pressure, we have so many different combinations, so many units, different types for pressure. When we do pressure as a topic, I will explain all of those. Finally, I want to, let me just do for energy. Energy and work, they have the same units. Energy and work. Because they what now? It's force times distance. Sorry. Force times what? Distance. Force times what? Distance. We give you what? Force times distance. What do we say force is? Force is what? Kilogram. Let me not take it so far. We say force is Newton, right? And then distance is meters. Distance from length. From length you get distance. So I can say that this is what? Newton times what? Meters. So give me what now? Newton meter. That's force. Newton meter. However, if I'm going from the fundamental, we have said that force is what? Force is kilogram meter per second squared. So if I multiply with distance, it's going to be what? Kilogram meter squared per second squared. This is correct. This is also correct. However, because of the fact that Joe has to be honored too for the work that he did, the unit of work and energy is said to be joules. just J, joules. So this will represent this or what now, or this. Then finally, last but not the least, I'll talk about power, and I'll stop here. For power, power is giving us work over time. Work over time. The rate at which what now work is done is what? Is power. The rate at which work is transferred is power. So let's say that work is what? Is joules, and time is what? Is seconds. So work is going to be what? Joules per what? Per seconds. And then we can go about from the kilometers, blah, 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 and all of that, but I just want to stop here, joules per second. However, just like the other people, watts also did a lot of work on that power. So to honor him, the unit of power is what now? Is watt. But you can have all the others in examination and then just understand how you're going to go about it. I will show you one more thing, and then the class is going to be over. Alright? Okay, this is just a summary of the first six. I want you to do the rest by yourself. I just summarized the first 6 for you. I give you so many others, or rather a few others. You do them by yourself. There's pressure, there's power, there's work, there's all the others. You do them by yourself. This is a summary for them. These ones on this side, they're called dimensions. These are dimensioning. These ones are the dimensions and all of that. Is that right? Thank you.